All right. This says to rewrite the standard form quadratic functions in factored form. So that should tell you that you're going to need to factor each of these. And remember, the general form for factored quadratics is f of x is equal to a times the quantity x minus p times the quantity x minus q. And
I found this on the web.
oh, thank you. It's so helpful. She found it on the web. So, um, that's the general form. So none of these, well, I take it back. A here is 1, 1, and 5. So that's our A value. So on that third one, it's a little tougher. I hope you remember how to do that. We'll get to it. And if you have questions along the way, please do ask. So we have f of x, that's our function notation. And since there's no a value, I'm going to have two binomials here. Since this is an x squared, it's going to be x times x, that's x squared. So remember, we're doing the inverse of FOILing. Factoring is the inverse of FOILing. Now, I look here, and this tells me that the product of these two things has to be negative. The only way that can happen is if one of them is positive and one of them is negative. Now, this times this has to equal negative 8, and and this plus this has to equal the negative 7. So that's going to be a negative 8 and a positive 1. Now, you can use the uh, box and diamond method. Absolutely, use the box and diamond method if that works for you. Uh, if you don't need to use the box and diamond method, great, don't use the box and diamond method. I won't be using it as I go through these. Callan, good morning. Good to see you. Hmm. Callan, or excuse me, I have someone having an issue getting in. Let me send them a link real quick here. And remind is a great way to let me know you're having issues. It's the easiest thing, easiest way to get a hold of me. I'll get a message right away and I can send you one back. Let's see if this helps. All right. So the next function that we're going to factor there, f of x is equal to, and again, a is 1, so we're going to have two binomials with our a value out here, 1. X times x is x squared. Now I notice that this is positive here, so the product of these two has to be positive. Well, that could be positive, positive, but then that would mean this was positive. So it has to be negative, negative. So I'm adding these two together and getting a negative, and multiplying these two together and getting a positive. So now I say, all right, well, what times what is positive 18 and adds to negative 9? Well, negative 6 and a negative 3 is what works there. Hazel, it worked. Yay, I'm glad to see you here. Good morning. Sorry, I don't know what was happening. Maybe come by during asynchronous today and we'll figure out what happened. On the third one, when our a value here is 5, is something other than 1, it needs to be factored out of everything, if possible. So here we have our first step here. Because 10 and 5 are both divisible by 1, we can factor out that 5. And when we factor it out, factoring it out of this leaves us with an x squared. Factoring 5 out of here gives us positive 2x. And factoring a 5 out of here gives us a positive 1. Now I can factor this part if possible. Let's see if it is. It seems to be possible because it says to rewrite in factored form. So that 5 still stays out front, and then I'm going to have two binomials that I'm multiplying by each other. X squared means that I'm going to have x times x. This, well, first I look here. So they're either both positive or both negative. But if they were both negative, this would be negative. So it's got to both be positive. And then what times what is 1? Well, 1 times 1 is 1. And then when I add those together, I get the 2. So that is the factored form. Are there any questions on factored form there? You can send me a question through Remind, or just raise your hand here, or just start talking. All right. I'm going to stop recording for a moment. Okay, folks, so here we have the three forms of quadratics: standard, factored, and vertex form. What do you get from standard form equations when you think about the graph? So here's our standard form. What does it tell us about the graph? Any brave volunteers out there this morning? The vertex. No, not on standard form. Any other guesses out there? Everyone's feeling a little shaky now. I'll tell you, it's got to do with this right here. Gives us the y-intercept. So the y-intercept is 0, c. And one way to think about that is if you put 0 in here for x, this would become 0, this would become 0, so y is equal to c. So when x is 0, y is c. That's one way of seeing it. All right, now in factored form, what do we get from factored form? Anyone willing to go out on a limb this morning? You get the x-intercepts. And that was Vincent? Is that who that was? Awesome, Vincent. Yeah, you get the x-intercepts. And so one of the x-intercepts is p0. So when x is p, y is 0. And the other x-intercept is q0. Awesome, Vincent. Thank you for just turning on your mic and going for it this morning. That's exactly what I couldn't be happier. Thank you. All right. Now, from vertex form, what do you think we get there? The vertex, Shady. Thank you. So we get the vertex in vertex form. And again, thanks for just speaking out. So the vertex here is HK. So here is our H, here is our K. Notice that it's X minus H, but it's plus K. So if this is X minus 2, then H is 2. If it's X plus 2, then H would be negative 2. All right, so it looks kind of reversed. Any questions on what you get from, what do you also get in all of them? There's one more thing that you get in all of those different forms. Shady. Yeah, you're on the in the right direction, but slope is something we talk about when it's constant, like in a line. But so when we're talking about a parabola, we don't use the word slope, but I think you're on the right track in thinking. Can you refine what you said in any way, or can anyone else? Yeah. We it's like the stretch. So stretching, you have this parabola like this, and it stretches and gets skinnier. Or you have this is your basic parabola, and it squishes and gets squishier. So so it's the stretch compression. But what else is it? There's one more thing the A value tells us. Yeah, opens up or down. And was that Sam or someone else? Sam, yeah, thank you. Thanks. Awesome. Yeah, if it opens up or opens down. Cool. Great job, everybody. So I'm going to highlight that red in there just to make sure that that we get this A value here. All right. So now, when we're converting between quadratic forms, so for instance, from standard to factored, so again, standard form is this one here. So if we're going from that to factored, well, then that's just like our warm-up problems. You just need to factor. If we're going from factored to standard, then we need to FOIL. So in this example, this is in factored form. Foiling would mean going, well, let's go through one real quick. So my first step is going to be to, you can do it in different ways, but I'm going to deal with these two binomials first. So I'm going to leave that 3 alone. And the result of foiling, first, x times x is x squared. And notice that I put this in parentheses here because I have to multiply the 3 times the result. FOIL. Outers, x times negative 5 is minus 5x. Inners, 1 times x is plus x. And lasts, 1 times negative 5 is negative 5. Now my next step here, I'm going to do 2 steps in one. So I'm going to combine this negative 5x and positive x. That'll be a negative 4x right there, negative 4x. And then I'm going to multiply that by the 3. So that's what I'm going to do in one step. But first I have to do 3 times x squared is 3x squared. And then this negative 4x times the 3 is negative 12x. And I'm okay with you doing those in one step as well. And then 3 times the negative 5 is negative 15. So we went from factored form to standard form. So standard to factored is just like the warm-up, factoring. Factored to standard, we use FOIL. Now vertex to standard, so if you start with something like this, that's vertex form, you're going to FOIL again. And so let's go through that really kind of quickly. So again, I'm going to leave that negative 2 out front, but what I'm foiling, and I'm going to write it out because I've noticed that this is a problem for some folks going from this to that. It's often useful to write it out. So what this is saying is the quantity x plus 1 times itself. The quantity x plus 1 times itself. So that's useful to write it that way. Whoops. And then now I'm going to FOIL those two binomials. So x times x is x squared. x times 1 is 1x, or just x. 1 times x is x. And 1 times 1 is 1. And then I still have that minus 4 outside. Now I'm going to distribute that to negative 2. So we have negative 2x squared. And then here, this is plus 2x. Plus 2x times a negative 2 is minus 4x. Then we have plus 1 times a negative 2 is negative 2. And then we have that minus 4 on the outside. So finishing that out, we have minus 2x squared minus 4x minus 6. Now, after we're done with this one, I'm going to have us get up and move. We've just done talking about it. So vertex to factored is going from something like this, but we have to go into standard form the way we did here. So we get it into standard form, and then we go into factored form, which means going from standard form to factored form, which is what we did in the warm-up. So when you're going from vertex to factored, you have to go through standard. So first you FOIL, then you factor. Any questions there? All right, let's take a minute to move our bodies and get the blood flowing back to our brains. Moving along here. Now, so we want to talk about converting to vertex form. So here we have vertex form. So if we have something in standard form like this, do folks have ideas like, oh yeah, I think I see what we would do to convert to vertex form? Any possible methods, techniques, strategies? Yeah. So it is completing the square. That's what we're going to do. So we start out with this standard form quadratic. And what I'm going to do is I'm going to take that x squared, and here it is right here, x squared. And if we think about generic rectangles, x times x is x squared. So remember, x squared is really the area there. And then we have this 12x. So x times 12 is 12x. But in order to do what we need to do, we are going to split this 12x into two parts. So here's our x, that's just like that. But that 12, we divide it by 2 to get 6 and 6 plus 6. And then x times x is 6x. X times x is 6x. And then we take those two rectangles and we bring them over here. Now, this is not what you're going to need to do when you're completing the square in the future. I'm just giving you a visual understanding of what completing the square is. So my first step when I'm completing the square algebraically is I break the c, minus 28, off. I break it off and I put it on the outside of some parentheses where I have my x squared, I have my 12x, and then I have this blank, which I associate with that blank. Okay, so I put two blanks in there. So what completing the square means is I'm going to make this into a square. So I have to put something here to complete the square. And what is it that I need to put there? Does anyone Can anyone look at that and know what I need to put there? What goes here? That's the question. Well, here's how we do it. Yeah, go ahead. I heard somebody click on. Yeah, 36, David, you're right. Nice, Thomas. So our b value here, remember in a standard form quadratic, our a here is 1, our b is positive 12, our c is negative 28. So we take our b value and we divide it by 2, and then we square the result. So 12 divided by 2 is 6, and then we square 6 to get 36. Now we take that 36 and we can fill it in to the rectangle down there. So if we don't have this rectangle, we still know that it's got to be 36. Okay, so we can move away from the rectangle, but it's a good visual to have while we're doing this. Then that 36, so the 12 came down here, we divided it by 2 and squared the result, which was 6 squared, which was 36, which goes right here in the rectangle. And in the algebraic version of completing the square, we add 36 here. But if we just added 36, then we've changed our equation. And we can't change the equation, we're just putting it in different clothes. We're making it look different. So instead of changing the equation, we need to keep it balanced. So if we're adding 36 here, what do we need to do out here to keep the equation balanced? Anybody willing to go out on a limb? When we add 36 here, what do we need to do out here to keep it balanced? Yeah, Lee Reed, David, you're both right there. We subtract 36 to keep the equation balanced. All right, so because we added 36 in here, we have to subtract 36 out there to make a 0. So there's no net difference between the original equation and the new equation. These two equations right here, those two functions, are equivalent. So now the next step, remember what we're trying to do is get this in vertex form. We're not there yet, but we're getting close. Because if we factor this, then we get the quantity x plus 6 squared. And that's the nice thing about completing the square. Look, we have this square here. And then negative 28 minus 36 is a negative 64. So what I want you to notice is that this number right here, plus 6, is half of positive 12. That's a big thing to notice. Okay. Questions. So here we completed the square visually, and we've done it from here to there algebraically, and that algebraic and that visual completing the square should match up in your mind. Are there any questions before we practice a couple of these? All right. So I'm going to do 2, and you should be taking notes. As I go through these and asking questions. Ask questions on Remind or just start talking, either way. So again, I start here. F of x is equal to, f of x is equal to, and so we separate out that minus 34 like that. So I'm going to see, hopefully we have enough room here. So what I do then is I take that 6 right here, and I do 6 divided by 2 squared. Well, 6 divided by 2 is 3 squared, which is 9. So here I add 9, and to balance it, I have to subtract 9 out here. Now, I'm not going to factor using the generic rectangle and diamond, though that might be what you do. I'm just going to rewrite it in factored form. F of x is equal to, there's the a value is 1 here, so it's, and today we're going to be using a values of 1 all the time. So we have x plus, and again, whatever this is right here, this is what's going to be your b value. So x plus 3, quantity squared, and then negative 34 minus 9 is minus 43. And that is in vertex form. And we can see our vertex right there. Our vertex is the point negative 3, negative 43, because it's x minus h. So that means our h has to be negative 3, plus that quantity squared, plus k, so plus a negative 43. Any questions on that one? For the h there? Because in the general form of vertex, it's a times the quantity x minus h squared plus k. So if we plugged in a positive 3 for h, then it would be x minus 3, but it has to be plus 3. So the only way for us to have x plus 3 is if h is negative 3. Does that make sense, Thomas? Okay. All right. All right, for the next one, again, f of x is equal to, I'm going to break off that negative 40. And I really recommend that you do write, you take these same steps that I do. I think it's a good way of keeping track of the steps. So, well, whoops, let me move that down a little bit. I'm not there quite there yet. We're going to take this negative 8. So notice that this time it's a negative 8. And we're going to divide it by 2, then square it. Sorry about that. And so when we divide it by 2, we get negative 4 squared. And then the result is a positive 16. So we add 16 here, which means we have to subtract 16 here. And now when we factor this, again, this part tells us what our h is. So it's the quantity x minus 4 squared minus 56. Questions? I'll let you sit with that for just a minute. The vertex is 4, negative 56. If there are no questions, I'm going to go on and we're going to do one together. So I'm going to ask you all to tell me what to do. Can anyone just start off telling me where do we start here? First steps. Great. Thank you, Thomas. So we have the quantity x squared plus 14x, and then I do a blank plus 42 blank. Now what? Thank you, Jacob. 14 divided by 2, and then what do we do with that? Okay. So, yep. And but we're going to square the result. So 14 divided by 2, we're going to square that is what I was thinking of, Jacob. And my question wasn't very clear. So 14 divided by 2, that's 7 squared. And the result of that is 7 squared is 49. So now plus 49 goes there, and subtract 49 has to go on the outside. Finishing it up, what will f of x equal? Who's brave this morning? I've had a few brave people so far today. I've appreciated all of you. The quantity, close, Thomas, close. You're really close. Remember, this step right here tells us our h value. So what's it going to be? X plus 7, that quantity is squared. And then you're right, minus 7 on the outside. So here our vertex. This is our answer. We wanted to write it in vertex form, but I'm just reminding you of what the vertex is here. -7, -7 is our vertex. Thank you, Thomas. All right. Now, if there are no questions there, I'm going to give you guys about 2 minutes to do this, and then we'll go over it. All right, that's about 2 minutes. Is anyone brave enough this morning to share what they did? Walk me through this? All right, Sam, what did you do? Yep. Okay, all right. So let me see if so you went x squared minus 2x minus 1 plus 1, and then you had minus 41 out here, minus 1. All right, so I'm going to see if I can fill in an intermediate step that I think you did, Sam. You took this, I'm going to put those there. You took that -2 and you divided it by 2, which was squared, and you got -1 squared, which is 1. So you added 1 there, and then to balance it out, you did -1 there. Okay, all right, great. Perfect so far. Really good stuff. So, what do folks think? Anyone? There's a part that concerns me here. Can anyone identify what it might be? And Sam, thank you so much for volunteering. What do you see, Sam? Yeah, right. Because this tells us what H must be. We know that this has to be, whoops, not highlight it, get rid of it. This has to be a negative one. Yeah. But everything else is perfect. Yep. Good job. Are there questions on Sam's work here? Sam, good job identifying where things went awry. All right, so that's it for our instruction today.